Welcome. This is the review class for derivatives and trigonometry, so units 4 and 5. This is found on D2L. The test format, 10 multiple choice, 5 long answers. Let's get started. So the first question, what is the amplitude, period, and displacement of the trig function in radians? So we want amplitude, period, and displacement. This is clearly a unit 4 question, and we want the answer in radians. So amplitude, period, and displacement. Amplitude is A. So 1/3, exactly. 1/3 is our amplitude. That's a nice easy one. Period, P. We need to remember the formula. Do you remember the formula? We're going to need two things, period and displacement. It's faster to remember it than it is to go looking in your notes. Yeah, period is not negative 2 pi over b. It's 2 pi over b. Displacement will be negative c over b, all right? So you can always, yeah, you caught yourself. Oh, I see that, yeah, I see what you mean. So period, displacement, those are our formulas. Our b, if you've forgotten this is a, b, c, given by the equation itself. That's a, b, and c. So all we need to do is take 2 pi, divide it by b, which is 3/4. And this gets to my first note. This is 8 pi over 3. And many, many students say it's not that. Many students tell me it is pi over 6. I'm going to make a note. It's not pi over 6. And I'm going to show you multiple ways to put in this answer, because I don't want you making this mistake. So the fastest way to do this, in my opinion, is to just do it all on one line. So it would be 2 divided by, and then the problem is if you do this, this is wrong. Let me be clear. I'm doing a wrong step. I'm putting it in as I see it, 2, 3, 4, and press enter, you get 1/6, or in other words, pi over 6. The problem is this is 2 pi over 3/4. So you're dividing by a quarter. You need to use brackets because 3/4 is like a group. So we use brackets. We'll say 3/4. And then as you do that, you'll notice it's actually a different answer because it follows BEDMAS in a different way. So the answer is 8/3. Now, you can use your fraction button on your calculator to do this, but make sure that your top one is the 2. Again, I could put the pi, but just we know there's a pi. Just take it out and put it back in when you're done. When you go down, that's where you need to hit fraction again, because on bottom you have another fraction and it's grouped together. And the calculator will know what you mean, even if it looks the same. 3/4 is what goes underneath that. And if you press enter, it's 8/3. Okay, the problem is if you just set up two fractions like this, and you put 2/3/4, that says 1/6. It looks the same, but it's the way that I set up the group. You set up the fraction first, and you got to go to the bottom one and set up the new fraction, or else you're going to get a different answer. Okay, so we'll see a few of these today. The other way you can do this is, of course, the negative reciprocal. You take 2 pi, and instead of dividing by 3/4, you multiply by 4/3, and that would be the 8 pi over 3. So that's our reciprocal version of that, okay? So long story short, think of the fraction terms as being in brackets, and you shouldn't have a problem. Keep it in mind. It might come back. So what about negative c? Well, that's negative pi over b. And once again, we have the same issue, 3/4. And so that will be the same as negative pi multiplied by 4/3. So negative 4 pi over 3, which is exactly what Muhammad gave me. And that's great. Hopefully the rest of you have your brains on too. Hi, Zayed. Nice to see you. I didn't notice you come in. Sorry about that. So same process. Think of it as brackets, and then you can use any of the methods that I mentioned to get that. When I do this in my head, I multiply by the reciprocal. It's by far the fastest in my opinion. You just multiply 4 and pi, and then 3 stays on bottom. I'll show you one other way before we finish how to do that. So this is our answers. These are our three answers. If I was to ask you a multiple choice, this is your first real hint of the day. If I was to ask you a multiple choice on this, I would ask you for period or displacement. I wouldn't ask for amplitude because it's a little too easy for the amount of marks, but I would ask for period or displacement. So if you know how to do them, you shouldn't have any problem. Okay, let's move on to the next one. If you need me to go back and show you that again, I will. Just tell me, sir, go back to the first one. This one, let's do it. Once again, this is amplitude, or A, this is B, and this is C, including the sign. So amplitude, you get it for free. Period, I'll just call it P, is again 2 pi over B, which is 2 pi over 2 over 3. And the 2 over 3 is like a group. You have to divide it. You have to be very careful. The same thing as multiplying by 3 over 4, which would be 6 pi over 2, or in other words, that's 3 pi. So it's the same thing as multiplying by 3 over 2. It's 3 pi. Excellent. What about displacement, D? Once again, it's negative C over B. Let's go back to the original equation here. We have C and B. That's negative pi over 2. So it's positive pi over 2 divided by 2 over 3. And once again, think of it like brackets on top and bottom. You're thinking it's maybe pi over 3. It's not pi over 3. So let me show you multiple ways to do this. The first way would be take the top one and multiply by the reciprocal of the bottom one, 3 over 2. Multiply the top and bottom, you get 3 over 4. The top multiplies at the top, the bottom multiplies at the bottom, so I have 3 pi over 4. So I will box that in, but I want to make sure that you know how to do that in multiple ways. I don't know what my wife is laughing at, but she's having a really good time out there. Okay, so let me close the door. You okay? Okay. Let's show you, I'll show you on the calculator. This one's tricky on the calculator. I like to set it up in one big line. I don't like to use the fraction function because it's a little tricky. So I'm going to set up the pi over 2. Just ignore the pi. So 1 divided by 2, that's pi over 2, or 1 over 2. I put brackets, divide that by, and use brackets again, 2 over 3. And then if you press enter for that, that's 3 over 4. So it must be 3 pi over 4. All right? That's what we need to do. You need to treat it like brackets. If you don't have brackets, you would be saying 1 over 2 divided by 2 over 3. And that's actually not correct because that's trying to do 1 divided by 2 and then divide that answer by 2 and then divide that answer by 3. You're not trying to do that. You're trying to divide the first part by 2 over 3. So that would be 1 over 12, not correct. I want to give you one more method of doing these, okay? If you're really stuck, this is what you should do. In this case, multiply the ones that are furthest away together, you'll get 3 pi. Multiply the ones that are closest together, you'll get 4. Students like that one for double fractions, and it works really well for double fractions. But be careful, it doesn't always work out the way that you want it to, okay? Just be careful. Let me show you how this would work for the other types. In this case, multiply the ones that are furthest away, 2 and 3, you get 3, okay? Or 2 pi and 3 gives, it would be 6 on top and 2 on bottom. I'm gonna delete this one, but you end up with 6 pi on top and 2 on bottom, which simplifies to 3 pi. So it still works by working with the ones that are furthest away and keeping the one in the middle. Does it work for this one? Negative pi times 4 is negative 4 pi, and 3 is the one that stays on bottom. So working with the ones that are furthest away does work. Finally, the one on top and the one that's furthest away from it. So that's an 8 pi. And then keep the one in the middle, or the one in the center is the one on bottom. So choose the method that works for you. In my opinion, there is no best way. Whichever one sticks in your head. And that's this question's type done. You all right with that? Okay, great. I always have two liquids going on, water and coffee. All right, what's the amplitude, period, and displacement of each function? This is, of course, another Unit 4 question because it's trigonometry. It's actually the exact same question, but you need to do it from the graph. And some students find this more difficult, so you might want to pay close attention to this. It's saying here that you need to assume it's a sine function. Why is it saying that? I'll show you. If it's a sine function, then the original function should look like this. It starts at the origin, goes uphill first, and then down, and then back up. So I'm going to call it uphill first. When it starts, it goes up. Now the important thing, why isn't the second one sine? Do you mean this one? Yeah, this one, the important thing to mention, I'll answer your question in a second. Let me just draw this graph so that we're clear. Cosine starts like this. It starts at a top, comes down, and then goes back up. So it starts up. I don't know how to write that better. Y-intercept at y equals 1. It goes downhill. Now, to get to your question, why isn't it a sine function? Why is it a cosine function? Well, because it's, Ali got it actually. He just jumped in and was like, bam, Batman. Sine is cosine. It's just shifted. So, if we shift the sign a little bit, it is a sine function. Sine and cosine are actually the same function, just shifted. And so we call them different things. They're used for different purposes, but at the end of the day, they are the same. Short answer, displaced. Thanks, Ali. Jumping in out of nowhere to save the day. All right. What are we asked for? Amplitude, period, and displacement. Well, amplitude's very easy. I hope you can tell that. We just look, we either look at this or this or this. Just look at how far away it is from the center. It's 2. So you just can write the 2. You get those marks for free, basically. I'm not even going to keep those markings there. Just note that this is a equals 2. For period, that's going to be a little trickier. You need to make a smart decision as to what we're looking at to compare the period. And we have a couple choices, but for period, it doesn't matter what points we choose. It does, but it doesn't have to do with if it's sine or cosine. We just choose 2 points, which are the beginning of a new cycle. So I like to choose the tops if I can. I like to choose the peaks. And the reason for that is the period is the length of one cycle. In terms of like computer circuits and everything like that, it's the amount of time it takes for one cycle in radians. So notice in this case, it took 2 pi. Notice it's at negative 2 pi and it goes to 0, so that's 2 pi. And in this case, it's another 2 pi. So in total, it would be 4 pi. Let me write out the answer, and then I see your question there. I'm going to answer it. So this is 4 pi. So Ibrahim, you said, can you choose negative pi and pi? And no, you can't. Yeah, you probably caught yourself. I'm just going to write it out just in case anyone else was wondering. This is a half a cycle. This is only 1/2 of a cycle. It hasn't done the full story. So many students make that same mistake. A full cycle goes down and then comes back up and gets back to where it started, but it needs to go the full length of the curve. You need to tell the whole story and then it'll repeat again and repeat again, repeat again. So another way to figure out period, and many students prefer this method actually, is just look at where the start of your cycle is, whatever you've chosen, and then look at where the end of the cycle is and subtract them. So this would be final minus initial, or 2 pi minus negative 2 pi. That will also give you 4 pi. All right, so multiple ways of getting the same thing. I want to show you one more way to think about this. Again, it doesn't matter where you choose on the cycle. Just don't write this, obviously, but let me show you this. What if I chose different points? Well, I could choose those 2 points, or these 2 points, or I could choose these 2 points. I could even choose something in the middle, like these 2 points. I don't know why you would, but you could. The period is all the same. See how it starts again? You know, if I chose this point, oops, if I chose this, then it would be the start of one, goes down, and then starts again. That's still a full cycle. It's just a really bad choice for figuring out the period. You'd still be able to do it. It'll be 3 pi over 2 minus negative 5 pi over 2. Still 4 pi. It just doesn't make any sense. You're not making your life easier, and you should always be making your life easier, not harder. Okay? Long story short, the period is found by choosing 2 identical points on the curve and subtracting the distance between them, or seeing it visually. Has anyone done the displacement while I was talking then? Displacement, I think, in my opinion, is the most difficult one to figure out. You have to know that it's a sine function. If you know it's a sine function, you shouldn't have any trouble. So let me just shift this over so I have a little more space. Let me show you how I do this. I know that sine normally starts like this and goes up. So there's 2 choices as to where it is. I can either look at it, compare it to this, or compare it to this. There is no other choice for where to start the sine function. I can either put it to the left, and then that would be my curve. I could consider it that way. Or it would start here, and then it would continue onward if I had that part of the curve. What you need to do, the sine curve usually starts at the center. You need to say, what is the distance from where it is, where it should have been to where it is now? That's the displacement. In this case, we could say positive pi. I would call it pi because that's the closest one, and that actually would be the final answer. It's been shifted by that much. Or the other way you could do it is to go all the way over to the left and say, hey, that's my displacement. And you can say that is actually negative 3 pi. I see your question. Just give me a second. Yes, Mohammed. What if I started with fractions? How can we know them? Okay, so the next question one of the future questions will help with that. But for now, can I just be clear that this so far is okay? Because then I'll start answering that question that you just asked me. Everyone else, Ali, it's okay? So just be careful. There are multiple answers for displacement. On the test, because it'll be multiple choice, you'll pretty much just have the one answer. Just look carefully at the graph, see how much has been shifted. It makes a huge difference if it's sine or cosine because the displacement depends on it. Now, what you were saying, what if it was fractions? Let me just give you an example here. What if you had to deal with fractions? So let's just say that this is our line. And let's just say it was pi over 2 here. and not given. I think this is the same one we were just given. My strategy for this is what you're talking about, right? You know, you're given this and you need to find the ones in the center. Stop me if this is not what you meant. I'm just going to go ahead and assume this is what you meant. Is this what you meant? Okay. So my method is the easiest method in my opinion. Find pi and then figure out how many jumps. That's my pi. 1, 2, 3, 4 jumps to get there. So take pi and divide it by 4. Well, it's pi divided by 4. That's the size of one jump. Okay, so you meant without the pi. Well, let me finish what I was doing, and then I'll try to figure out what you're talking about. This is pi over 4. So you said, oh no, you meant without the pi. So you're going to have to clarify. I'm not sure what you mean. If someone else knows what he means, tell me. You said without the pi. Okay, let me look at the assignment and see if we can figure this out. So this is the assignment question. All of these, the fractions were all given. So I don't know. Yep. Go to this one. Okay, so about the fraction, what fractions do you mean? The pi, okay, so you mean this pi, I'm assuming. Is this the pi that you mean? Doesn't matter. It's still pi, and you can say, all right, 1, 2, 3, 4 jumps to get to it. So that's why the first jump is pi over 4, because pi divided by 4. And then the next one must be 2 pi over 4, because there's 2 of them, which simplifies to pi over 2. The next one is 3 pi over 4, which is the way it is. The next one is 4 pi over 4, because, well, that cancels, becomes pi. This one's 5 pi over 4, which stays the way it is. 6 pi over 4, which cancels down to 3 pi over 2. This is 7 pi over 4. This is 8 pi over 4, which cancels down to 2 pi. This is how we deal with this. So it all comes from figuring out what one jump is, and then just add one of them, 2 of them, 3 of them, 4 of them, 5 of them, and then they'll simplify. And that's where all those pi numbers come from. All right, we got there in the end. I really hope that that was your question. If it wasn't, I'll keep picking away at it until we figure it out. No, don't worry about taking my time. This is your time. This is review. The whole reason I'm doing this is so that my students are doing better. This is not for me. I know this stuff. Don't worry about me in this. The whole point of this is me to help you understand it, not the other way around. Where am I? Review. Okay. So I can remove this. This is just a side note. Anyway, we've done that. Let's do one more. I want you to try this. I want to get amplitude, displacement, and period for this cosine function. I'll give amplitude. It will be 3. What about period? This one should be an easy one. A is 2. Try again. Should be 3. Be careful, you don't want to lose that. Cosine function, cosine. Still asleep. Yeah. Period. We can do it multiple ways. I like to take the period of this one from 0, and then I can see it repeated over here. Okay. Again, the period doesn't matter if it's sine or cosine. It's done the same way. That's a full cycle, which means I can just judge that distance. This is my period. The period in this case, I can read it off the graph, 3 pi, not negative 3 pi, 3 pi. If you went the other way, you still read it from left to right. So you wouldn't need the negative. You can't have a negative period because a period is an amount of time. You can't have negative time. So be careful with the negatives. By the way, any of these periods will work. Look at this. You could choose these 2 points. That's correct. You could choose these 2 points. You could choose these 2 points. These 2 points. Oh, I see your problem. You chose negative 3 pi and 3 pi. Well, look at this. At negative 3 pi and 3 pi, that's 1 cycle, 2 cycles. We don't want 2 cycles. What would happen is you'd have 3 pi minus negative 3 pi, which would be 6 pi, but it's 2 cycles, so you divide by 2. I think you mean you chose negative 3 pi and 0, which would still be final minus initial, 0 minus negative 3 pi. Okay, I see it, 3 pi over 2. Yeah, so you chose this and this, which is perfectly fine. You chose it as if it was a sine curve. But again, take the final one, 3 pi over 2, minus negative 3 pi over 2, which is the initial one. That gives 6 pi over 2, which is still 3 pi. So maybe you had an algebra mistake. I'll leave that there for now so you can figure that out. But whatever way you get it, as long as you get 3 pi, is what matters. I'm going to erase this. Finally, the displacement, which in my opinion, is the hardest one. I'm getting negative 3 pi over 4. Let's see if you're right, Abdelgader. Once again, it's a cosine function, which is the green thing up top. So I'll put a little green star to remind you. Cosine starts at a top. So let's see, our displacement, we need to compare it to either this one or this one. And they're both perfectly acceptable answers. We compare it to cosine, normally starts right here. So we either go left or right. So the quickest way is to go left. That value, what you'll see here is that this distance is negative pi over 4, and it's negative 2 pi over 4, and it's negative 3 pi over 4. And that's why we have negative 3 pi over 4 as our answer, which means you're right. Negative 3 pi over 4 is my answer. Or, if that doesn't suit you, if you don't like that one, go over to the other possible place you could start. Again, this is displacement. The other possible place you could be is whatever this is. And I'll review one more time how to get that because it is important if it's not given. We know that this is pi, 1, 2, 3, 4 jumps to get there, so it must be pi over 4, which means this is 3 pi over 4. This is 5 pi over 4. This is 7 pi over 4. This is 9 pi over 4. So the displacement is 9 pi over 4. That one takes longer to get, but it's not wrong. There's nothing wrong with the answer. In fact, there are unlimited number of answers. There's infinite number of answers. Because if we extend the graph, it'll do this forever, as long as time is passing. Think of it like the wheels of a car. They go up, down, like the edge of the wheel. Up, down, up, down, up, down, up, down. It'll go forever unless you turn the wheel off, unless you stop driving. So just, of course, there's going to happen over and over again. So anyway, do we need to take the closer one? No. You can always take either one. But I will say that on your test, because it's a multiple choice, I'm only going to have one possible answer there. So just be careful. I think the graph will be clear, but just be aware there's more than one answer, and they're both correct. All right, are we good on this? So let me know if you need to go back, of course, always. It doesn't bother me. This is for you, not for me. Anything you need me to review or look at more closely, we will. But that's how this question is done. Once again, I'll be asking either period or displacement, and you'd expect it as a multiple choice question. The next question, you remember this? It looks scary, but honestly, there's not actually that much to do. It should be pretty easy marks. And this is also unit 4. So use 5 key points to sketch the graph of the function. Once again, the function's given, and we can grab our a, b, and c values directly from it. So amplitude is 2, that one's easy. This box is going to be displacement. All right, if period confuses you, let's work on it. So this is going to be displacement. I know that this is what? This is a sine function, and sine functions have this following form: 0, maximum, 0, minimum, 0. So we can already fill that out. My zeros go in, and then my maximum plus and minus. So 2 and negative 2. I already have all my y values. What I need now is period and phase shift. I know my displacement needs to go here, so I'm going to get displacement first. Doesn't matter which one you do first, as long as you get all the pieces, but let me just do a displacement. That's also called phase shift. Displacement is negative c over b. Negative c would be negative pi over 2. b is 3. What's negative pi over 2 divided by 3? This is a tricky case. The rule that I said earlier doesn't work as well, so you want to be very careful. It's pi over 2 multiplied by 1 over 3. Pi over 6. So Ali said, same, I did that question twice in unit 4 assignment because he got the period wrong. Yeah, the period and the displacement are tricky because if you get fractions, life becomes difficult. So once again, I'm going to review, probably for the last time, how to put these fractions in to your calculator so you can do the work for you, or you can do it by hand like I do. So once again, set up your fraction first, or use brackets. I'll use brackets first. So it's negative pi over 2. That is a group. It's given like that, so I'm going to say negative 1 over 2. And then you divide it by 3. Your answer is 1 over 6, negative 1 over 6. If you put the pi back onto that, it's negative pi over 6. If you remove those brackets, you will not get that answer because you're breaking the bed mass. I don't think you'll get it anyways. Well, you do. In this case, you'd luck into it, but it doesn't always work like that. So use the brackets. It'll ensure you get the right answer. If you want to set up the fraction, set up the fraction on top, or I've got the main fraction. I know on bottom there's a 6, but the top fraction is, sorry, the bottom is 3. Sorry about that. It's the top that has the group pi over 2. So I'm going to set up a new fraction there, negative pi over 2 or negative 1 over 2. I'll put the pi back in at the end. Negative 1 over 6. So negative pi over 6. Multiple ways to do it. In fact, I just showed 3 different ways to do it. Use the way that works for you. I don't know which way that is because everyone has their own preference, but be careful. And that's our displacement. I don't know why I wrote it so big. This is our displacement. So that's going to go in for displacement. Negative pi over 6. So when you said you got the period wrong, well, let's work on the period and see what happens. So displacement was asked. I'll write that in here. Just a way to keep track. Period, it's 2 pi over 3. Yeah, it's 2 pi over 3. So 2 pi over b, and b is 3, so it's just 2 pi over 3. That's our period. The reason we need period is we need to know what we add each time, distance between each point. So we just take our period answer, divide it by 4. That's our period divided by 4. That gives what? What's 2 pi over 3 divided by 4? 2 pi over 3 divided by 4 is the same thing as 2 pi over 3 multiplied by 4, 1 over 4. That's 2 pi over 12, or pi over 6. Another way to do that is, of course, set it up as your, in your calculator. I'll erase that in a second. So the period, you just had to be super careful. I always like to put it in my calculator. I would say brackets 1 over 3 divided by 4. And that'll give you your answer. It'll give 1 over 6. Okay? There's multiple ways to do it. Just find a way that works for you. Make sure you do enough of this practice so you can figure it all out. Now, why do we use this? This is what we add to the displacement. So add pi over 6, add pi over 6, and so on. Take your x value, add the displacement. What do you get? What's negative 1 over 6 plus 1 over 6? It's 0. What's 0 plus 1 over 6? It's 1 over 6, so pi over 6. The next one would be 2 pi over 6. 2 pi over 6. What's 2 pi over 6? It's pi over 3. What's 3 pi over 6? It's pi over 2. I'll write them down. This is negative pi over 6. Add 1 over 6, so it's 0. Add another 1 over 6, pi over 6. Add another 1 over 6, 2 pi over 6. Add another 1 over 6, 3 pi over 6. You see how these rules work? How these patterns come out of this? The reason why it gives us these weird fractions is actually just simplified versions of easier fractions. Anyway, our story is complete. I'll write in my period here because it asked for it. And now I need to graph it. So you can go ahead and try to graph it. If you don't have the graph paper in front of you, because you didn't print it ahead of time, that's okay. Just draw a little sketch. Some of you made some beautiful graphs for this assignment, like truly beautiful. So I was happy with that. Others not so beautiful. So let's label this graph. First things first, we need to make sure we have our points. This is pi, 1, 2, 3, 4, 5, 6 jumps. So this is pi over 6. This is 3 pi over 6, which we said was what? Pi over 2. This is 5 pi over 6. 7 pi over 6. This is 9 pi over 6, which is actually 3 pi over 2. Remember 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, blah, 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 negative pi over 6. We know that the distance between each is given by this. All right, so multiple ways to get the same thing. Let's fill in our sketch. Negative pi over 6 and 0. 0 and 2. Pi over 6 and 0. Pi over 3 and negative 2. And pi over 2 and 0. So I'll sketch this in. I won't be so careful with it. I'll just make a nice curve. I had some students, no lie, give me this. That is not sine. Sine is a curved function. It is very smooth. It's like wheels of a car going around and around. It's a very smooth motion. It doesn't go like a square. It doesn't work like that. It's a sinusoidal function, not a triangular function, in other words. Some students like to continue it. There's nothing wrong with that. It would look like this. And students know that the pattern would continue, which is why they like to continue the pattern. It's up to you. It depends on how much you want to draw. Okay? That's the whole question. Is there anything in this question that I can go back over? Because the last time you're going to see it, possibly in the whole course, because there's really not much final exam review. Happy to hear it. Let's move on then. Ooh, Unit 5 begins. The rest is Unit 5. Also, as a reminder, there are 10 multiple choice, 5 long answers. At this point, you should be playing a little game with yourself, making a tally and saying, which questions would be multiple choice? Which questions would be long answer? Which question could be given as 1 mark? Which question could be given as 4 marks? You should be able to think these things through. Okay, let's do this. We didn't do one like this on the assignment, but you'd be expected to do it on a test. And they're not difficult, so it should actually be a nice thing. And by the end of this set of tables, I think you'll be okay. So we did this in class, actually. It says, use the table to determine the limit as x approaches 2 from the right of the function f of x. So what this means is that we have the value of 2, x equals 2, and we want to approach it from the left and from the right. So we get closer and closer. On the left side, something close would be 1.9. On the right side, something close would be 2.1. And we want to get closer and closer, 1.99, 1.999, 1.99999, and closer to 2. Really, from the right is going from this side. Let me get straight to the point. From the right, we are doing these. 2.1, a little bit closer, 2.01. That would give the value of 6.01. As we get closer and closer to 2, the value that comes out is getting closer and closer to 6. That is what limits mean. So, with that in mind, the limit as x approaches 2 from the right, and it's from the right, that's why we have a positive, of our function, we don't know what it looks like, and it doesn't matter because it's giving us the y values. What is the answer? What value is, what is it trying to get to? What is it getting closer and closer to? What is the limit, in other words? 6. The y value. Of course, we're getting closer and closer to the x value of 2. But look, what happens is, as we get closer and closer to this, what value is f of x? It's saying, as x approaches 2 from the right, what is the value of the function? So as x approaches 2 closer and closer from the right, 2.0000001, 2.000000001, it will get closer and closer to 6. If you have 6.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000do I ruined it. Basically, I have the number 6. So this is why we have the answer 6. Let's do more of them so that it's getting closer and closer to you understanding this. The limit as x approaches, I get it, sir. That's our limit. Okay, use the table to determine the limit. As x approaches -1 from the left, well, let me draw a little number line. You don't need to. So -1, that means that 0 is somewhere over here. Let's go from the left side. Something more negative than -1 is like -2, right? So really, you'd imagine -2 would be over here somewhere. So -1.1 is over here somewhere. And as we get closer, it's 1.01, 1.001, and so on. On the right side of it is actually -0.9, which is why students sometimes have trouble with this. So think about it clearly. But let's just go to the point. From the left, as we get closer and closer and closer to -1 from the left side, we get closer and closer to this. Okay, 99, 999, 999, 999, 999. You're saying 100,000. Think bigger, Ibrahim. If we continued the pattern, if this kept going, 1.0000000000001 would be 999999999999999999999 forever. Bigger, 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 bigger. Put that number in your calculator. 99999999999999999. It's massive. It just gets, it goes to infinity. The whole point is it's going to millions. It's going to be millions and millions. It gets bigger and bigger. So the limit as x approaches -1 from the left, our function value, it gets so big that it goes on forever, infinity. Infinite. Yeah, infinity. Infinity is my point. Because again, the whole point of the limit, it doesn't stop here. It doesn't stop at -1.001. It means we're getting even closer. Like you can always get closer, 1.000000001, or even smaller. You can always go smaller. So that means that the pattern is going to continue. So it'll get bigger and bigger. It goes to infinity. Okay, let's try a couple. Someone tell me what the answer to this is. They're really fast once you know what you're doing. It's 2 from the left. That means 1.99999. That's from the left, yeah? If you have 2, then 1.9 should be over there. So we're getting closer and closer and closer to this value. Means we're getting closer and closer to this function value. So the limit as x approaches 2 from the left of the function is what? You don't need that 5.0000. It goes closer to 5. No one's saying anything about 5 here. There's no 5. There's no 5. If anything, it would be 4.9999999999999, which is 5. If you round it up, it would be 5. If you had 5.99999999999 reals, are you going to pay someone 5.999999999 reals? No, you don't even, money doesn't even go that close to the decimal. You just round up. 5. Take the closest whole number. If I said from the left, as a little extension, if it was the limit as x approaches 2 from the right, then it would be this one. It would be 6. The y, so sorry, the y values aren't that close to 5. I don't understand your question. It just means if we were looking for the overall limit, like from the left and the right together, then we would not have a limit. But from the left, there's always some sort of limit from the left and from the right separately. It's when we put them together that the total limit doesn't exist. I'll show you what I mean. The last question is a really good example of that. So it says, use the table to determine the limit as x approaches 2. So the definition of the limit, in order for it to exist, we need to check it from the left. We need to check it from the right. And they need to be equal. Are the limits equal? Question mark. In this case, no, they're not. And it's very easy to tell because we say from the left side, I gotta get my colors right. From the left side, it equals 5. From the right side, it equals 6. So the final answer, let me write this out. The limit as x approaches 2 of the function is non-existent. It doesn't exist. And the reason is, it's because, let me bring this down, sorry, I'm not thinking ahead enough. The limit from the left and from the right are not the same. If they were the same, then it would exist. So I'll write a little extra because I know a couple of you are still struggling to make sense of this. The limit as x approaches 2 from the left is 5, which is not equal to the limit as x approaches 2 from the right, which would be 6. Okay? They're not equal to each other. So if the left and the right side are not agreeing, it doesn't exist. It's like in theory, if you know, okay, let me see, Ali. That's what I was saying, but something that's confusing me is that the previous table has the same values. It's irrelevant. It makes no difference. I think what maybe you missed was this. Let me zoom in on the important information. Look at the difference between this. X approaches 2, just 2. This table asks you 2 from the left. That's what that little minus means. So I'll keep my colors consistent. Those are the differences. And yeah, sorry, I didn't catch what you meant, but I understand it now. It makes a huge difference. If it says from the left, look at the left side. If it says from the right, look at the right side. If it says just the number, you look at both sides and tell me if they're equal or not. That's the big idea. That's the main concept, the big picture. So now let's look at them all and see if we can appreciate what's going on here. From the right, 6. From the left, infinity. The limit from the right, -1 from the right of this function would be negative infinity. The third one, 5. The fourth one does not exist because of the big difference here. More clear? I felt like maybe you were struggling with limits, which is why I put this together. The limit means what value would it get to if we continued this pattern. Second one doesn't have decimal, that's why it's infinity. It has nothing to do with the decimal. It has everything to do with what's happening to the f of x values. So let me look at this. I'm just going to copy this over here. It's basically like finish the pattern, okay? Let's finish the pattern. 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9. How far do I go? How long do I continue this? What's our limit? Is it going to go to a specific number? Well, no, we can always add a 9. We just add a 9 to the end. And if someone asked you to do this, you would be there all day. It would continue. It goes forever until we fill the whole page with 9s. Remember, those are numbers. If you had that much money, how much money would you have? More and more money, forever. It goes to infinity. Same idea that if you had a negative, 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 you would have a negative infinity. You said, can you show me with a decimal? Of course I can. So let me give you another case. What if our function instead was talking about 1.01, and you add a 1 in there. So you have 1 real and 1 dirham. And then you have 1.001, which is even less or even closer to 1. You know, you have a milli, what am I trying to say? A thousandth. You have 1.0001. Well, that's of course closer to 1. 1.00001, that's even closer to 1. 1.000001, that's even closer to 1. After some point, you know, after time, you're going to have so many zeros that essentially you just have 1, because like, who cares if you have a 100 billionth of a number? It just disappears after a while. It's so small that it doesn't matter anymore. It's like you have 1 pizza and divide it by 10. Okay, now you have 10 slices. Divide each piece into 10. You have a lot less pizza. Keep dividing something in 10, and you essentially, it just disappears. at the end of the day, this equals 1, is my point. And this equals 1 to infinity. Can a decimal be infinite? Once again, it doesn't have anything to do with the decimal. It has everything to do with what number it's trying to get to. Let me show you one more thing, because we're spending way too long. This is 1 mark. This is 1.01, or just imagine, 1.01. If we move it closer, it's 1.001. If we move it even closer, it's 1.0001. If you move it even closer, it's 1.0001. If you move it closer and closer to that number, as you get closer and closer and closer, what number are you getting to from the left? It's becoming 1. That's your limit. It has to stop somewhere. It has to stop at that 1. So yeah, don't worry about the decimal so much. It's just look at the number in front of the decimal and just steal it. Okay. Let me erase some of this extra stuff. Someone just came in. Who is it? I think someone just popped them back in. All right. The graphical limits. They were done, probably the worst done question on the whole assignment, which I was kind of sad about because I thought I'd gone through this question many, many times. Let's take a look at this. Limit as x approaches -2. Well, just find -2. This is x equals -2. And just tell me, from the left, what is it going to? And from the right, what is it going to? From the left side, it's going to -infinity. From the right side, positive infinity. They don't match, so it does not exist. In other words, the left-hand limit, the left side limit, and the right side limit, the right-hand limit, are not the same. Okay, that's for the first one. I made a little typo on the second one here. Change this. It's not x equals -2. I'll make it -1. Did I submit the marks? No, that'll be done after this class. I haven't finished yet. I just finished marking. I haven't had a chance to tally them up yet. So you'll get your marks, I would say, within half an hour of the class ending. I'll just work on that. Okay, so what is the limit as x approaches -1? What we need to do is, let me show you. Look in on -1. From the left side, what's the y value we're trying to get to? Well, 1. From the right side, what's the y value we're trying to get to? 1. So the limit's 1. All right, we're going to do 5 more of these. And hopefully by the end of this, you'll be experts at limits. Let's look at this next one. The limit as x approaches -1. This was like your assignment question. This line. Well, from the left side, it says it's 1. From the right side, it says it's -2. They're not the same. Does not exist. Two different values. The limit as x approaches -4, left side says infinity. Right side says infinity. They agree. Must be infinity. You just tell me what's happening on the left, what's happening on the right. If they're telling the same story, then the limit exists. In the other case, of course, this was a 1 and this was a 2. So we don't have the same story being told. So the limit doesn't exist. Let's do this one. You tell me. Tell me what the first one is. Tell me what the second one is. First one does not exist. I agree with that. -3, because this person is saying, hey, it's going to infinity, and this person's saying, no, it doesn't, it goes to -infinity. Exactly, Ali, it's all three of you are saying the same thing, or all two of you, sorry. Second one is -2. Let's see. Someone is saying from the left, it's 2, sir, -2. From the right, it's 2, sir, -2. Yeah, it's -2. Eventually this will click and you'll say, oh, really? We're just telling what number it looks like on the left and what number it looks like on the right. And if they match, it's the limit. Yeah, that's correct. Let's try this one. Limit as x approaches -2. We don't need workings for this. -2 over here. Left and right, clearly the same. 1, 2, 3, 4, 5, 6. The y value 6 goes towards a nice number. As x approaches 4, so we're looking at this line. Left side says 3. Right side says 1. Doesn't exist. You starting? Is it starting to click? Let's keep them going. This middle one, limit as x approaches 1. -1. Left side says -1. Right side says -1. X equals 3. This one. Right side says infinity. Left side says -infinity. They can't agree, and so it doesn't exist. I hope this is becoming clear. That's why I put this here, so that you'd see so many that you go, oh, really? Okay. One last one. Let's finish strong. X equals, or x approaches 1. That's this point. On the right, they say 2. From the left, they say 0. Can't exist if it's saying 2 and 0. Those are two different numbers. Finally, what is the last one? Can I get some answers in the chat? Let's blow up the chat here. I see a 3. I see a 4. One of you miscounted the number of jumps. Yeah. Two of you, I think. Ali and Muhammad first wrote the wrong answer. Let's just be clear here. What y value is this? 1, 2, 3. 1, 2, 3, 4 jumps. From the left side, they say 4. From the right side, they say 4. So the answer must be 4. Okay. Now that you've got your limit superpowers, I will do the delta process. It'll be fully covered on this review. Actually, it won't be because I'm not putting the delta process on the test. So maybe if you want to know the delta process, you can just go back and watch the videos. I want to bring up the assignment. Do you see what this question is? Look familiar? Does not exist. Left and right don't agree. When x is 3, 1, 2, 3. We just did this question. From the left side, 4. From the right side, 4. That's what the limit's for. Yeah, a few students, I would say 20, maybe even 30% of the students got it wrong. Maybe more. Yeah. Maybe almost half. I haven't done the math on it, but many students got it wrong. Okay. Ali, I can go through the delta process again. It's just not going to be on your test, so I feel like maybe it's not the smartest thing to focus on today. Okay, yeah, just go back through. And of course, once you've watched the video, if you want me to explain it fresh, I have no problem doing that. It's just today at this time is not the right time. You can just ask me a different time, and I have no problem going through it at all. Okay, so first things first, determine the derivatives. What's the derivative of this? Many students look at this and say, hey, e is a variable, okay, so it must be 2e, and they go ahead along their merry way, which is not correct. E is a constant. It's a special constant. In fact, if we were to get the number, you can type it in on your calculator and get this number, 8281828, dot, dot, dot. It continues forever, just like pi. It's just as special as pi is. It's used in many similar ways. It's 0. It's a constant. A derivative of constant is 0. So for the next one, y prime, again, 7 pi, pi also a constant. Is this section 3's assignment? This one here? No, this is a review sheet. For those who don't know, I made this new yesterday. This is test 2 review. It's on D2L. It's at the very top of the news feed. You can find it in content too, but I made it for you. Yeah, I jumped back. I didn't put this stuff on their assignment. I keep your assignments similar. They have similar questions, just different questions, different numbers. So this is 0. And in case it's not clear, pi is a constant. What about the next question? Well, sine of pi over 2, cosine of 3 pi, tan of pi over 3. If you were to put those in on a calculator, they all give numbers. They don't have an x. They are all constants. They're all sorts of different numbers, but they're all constants, which is why we have this. They're all constants. So the reason I'm bringing this up is maybe this would make a really nice, simple multiple choice question. E is a constant. Pi is a constant. Anything with sine and cosine and tan that doesn't involve x, you know, if you have an e or a pi or any number inside, they're constants as well. So just be careful, pay close attention, and you'll get that multiple choice right. Okay, now we're into the sort of stuff that we saw in the assignment. Let's get her done. First things first, what rule am I going to use? This is clearly a product. It's f prime g plus fg prime. Many ways to do it. I like my way. Many students like their way. It's okay. You can find 100 different methods on YouTube, and they're all equally good. Just depends on the student. The derivative of the first one times the second one. Plus the first one as is, or f, and the derivative of the second one, 6x squared minus 20x power 4, and 1 is a constant. F prime, or sorry, f prime f, g prime. I won't write this out every time, but just to be crystal clear here, these are my numbers. Product rule. I'm not going to spend much time on that because most students got that in the bag. This would be a multiple choice. This wouldn't take the, you're stressed and didn't think about doing that until I noticed B was quotient rule, yeah. We don't need to simplify. We don't simplify in this course. It's not necessary. You can keep it like it is. It's a perfectly valid function. You're only going to make it more complicated to begin with. It will simplify after time, but you don't need to. It's just a waste of time. The first B here is quotient rule. I'll write it down clearly. F prime G minus F G prime all over G squared. So let's see what this gives us. We have 5 minus 3x squared. So with the derivative of the first one times the second minus the first one, and the derivative of the second, all divided by the bottom squared. So that's once again finished. I won't highlight this every time, but I will highlight it this time. F prime and F, G, G prime, G again. Okay. Man, I'm so stiff. So much standing. So much standing. Okay. If you have questions, let me know. Otherwise, I'm going to keep going through this, all right? C, or C prime. What do I have to do for this? Power rule. It's definitely in power rule form, but when it has a function inside, we have to call it the chain rule. Because we don't just get the derivative of the outside, we also get the derivative of the inside. So when you do one big chain of functions, it's chain, yeah. Power rule is if you have something like this, Mohammed. You just have a constant and a simple x. Chain rule is if we have that form, but there's a function inside. That's the difference. But as long as you know what you're doing, it doesn't matter what you call it. You can do it in any language. Math is its own language. So I bring the 3 down. I'm going to keep the inside the same, and I'm immediately going to write the 2 on top. And that reminds me to reduce it, because a lot of students forget the power. They bring the 3 down, you keep the inside the same, and by the time they've copied that out and thought about it, they forget about the 2. They don't write it. Many students make that mistake. So don't be that student. Now we're going to get the derivative of the inside, which is 6x minus 4. One thing I want to be very clear about. Oops, that's not as clear as I wanted it to be. You need the brackets. If you don't use the brackets, it's a totally different function. If you don't use the brackets, you'll be only multiplying 6x by everything and not the 4. Anyway, remember the brackets. Basically, every time you got your new derivative, you'll use your brackets. And as a recap, the derivative is the derivative of this one. Okay, again, stop me if you need me to. This one, again, hey, looks familiar. I have a feeling it's product rule. I'll talk it through. You can try it yourself. I'll do these very quickly. Derivative of the first one times the second one, plus the first one as is, multiplied by this derivative of the second one. Some students, sorry, I did the, you can hide the answer. You can do this one alone. Sorry, I didn't look up in time. So check your answer with D, try H, tell me what you get, and then I'll be back in a minute. I just need to get a bit of water. Tell me what your answer to H is. Once I have 2 answers in the chat, we'll move on. Anyone get it yet, or are you struggling to write it in the chat? Six x squared minus 4, x squared minus 8x minus 2x cubed minus 4x, 2x. So you've got a bracket there that shouldn't be there. And then all over x squared minus 8x, all squared. So Ibrahim, you have an issue. You have a 2x minus 8. You put a bracket in the wrong place. So it should look like this, which is pretty much exactly what you wrote, except for one or two tiny differences. And the differences matter. Every single one of these changes in brackets, if you type a number wrong or write a number wrong, it changes the function if you graph it. And that makes a big difference. That's not a good thing. So this should be the final answer. The most common mistakes are this, or missing some brackets in weird places, or forgetting to actually put in every single term. You should always have 4 terms on top, 1 squared term on bottom. Is that okay? The answers look good. Oh, sorry, my back, I've got a very bad back. It's been bad for years. On a steakhouse fixing it. All right, let's do kx. What's this? Chain rule by the looks of it. So this one should be really fast, really easy marks. What's it going to be? I'll do it slowly so you have a chance to do it yourself. I'll just write it. You can write it down yourself and see if it matches mine. I won't say what it is. Let's just put that there. Yep, looking good. Square. Don't forget that square. That's a big, it always happens. Lots of students forget that one because for the reasons I said, you bring the 3 down, you copy this, and by the time you're done that, you forget to write the 2. I'll take it as a typo. Okay, I'll believe you. Chain rule, for the same reason as before. Some students like to multiply these together, and that's fine. You could get for 6x minus 6 and stuff like that, but there's no need to simplify, so let's not waste our time doing that. Let's do the next one. This one is big, a little bit tricky. Could be a very nice long answer question. This one, if we look at it, actually has x cubed form. So we're going to be doing the power rule, but when we do the power rule on functions like this, it's chain rule. And then inside the chain rule is a quotient rule. So yeah, so Mohammed, you got that. It's chain and quotient. So the chain first, it looks big and scary, but honestly, it's not that bad. Take the 3 down, leave the inside the same, reduce the power by 1. That is my entire chain rule done. Just keep the inside the same, copy it. That's all there is to it. You know, you can make your brackets fit better if you want. But that's the first part. That's worth a mark in itself. Yeah, I made a little simpler one. I don't know what you'll get on the test, but I don't want it to be insanity. You know, definitely make sure you go through the notes and can figure them out, but I just wanted to make it straightforward. So now that we've done our chain, we do our quotient. which we just consider the inside. This is the top, this is the bottom. And so just do your whole chain rule, or sorry, do your whole quotient rule in those brackets as a new problem, pretend the rest of the question doesn't exist, and you're done. So the derivative of the top times the bottom minus the top, the derivative of the bottom, all over the bottom squared. So the main things that people forget are this and this. I'm not writing this. It's that time of day, is it? It's a Thursday, you just don't have it in you anymore. All right, fair enough. As long as you understand, you can write it later if it comes up on the test or when you're practicing it. What's the next one? Fine, it's fine. We clearly need the derivative. I haven't given you very much space to answer it, which is usually a hint that you don't need that much space. Sometimes, anyway, when I make it. What's it going to be? Yeah. Definitely chain. The problem is the whole thing, we kind of have two chain rules, right? We have two pieces. We have this piece, which would be its own chain rule, and we have this piece, which would be its own chain rule. But when you look at the question all together, it's one big product. So you really need to do product rule, and then you need to do the chain rule. Just consider it like the product rule, and then if you need to get the derivatives, you'll do the derivatives as you go. So if this is the first one, what's the derivative of just the blue one? Okay, so the derivative of the first one, 3. Keep the inside the same, reduce the power. And now the chain. What's the derivative of the inside? It's this. Okay, that is the derivative of the first one. If you get that idea, then you should be fine to do the rest. So Mohammed, you forgot the -1 because it's minus x. And remember, that's a 1x. The derivative of x is 1, not 0. So the derivative of 7 4x is 28x to the power of 3. The derivative of negative x is -1. Oh, yeah, sorry, I forgot that x. So 28x cubed minus 1. Yeah. Thank you. The rest is okay as far as I can tell. Make sure that you have 28x cubed minus 1. That's the first one. Now I need to keep the second one the same, because remember, this is one big product rule. So this is g plus the first one and then the derivative of the second one, which is, let's see if we can end strong. Yeah, 11, 5 minus x cubed, 10, multiplied by its chain, which is negative 3x squared. Okay, so I can cheat because I have the technology. But you'll just need to write smaller. I write bigger so that you can see it properly. This is the big idea. She's long. I wouldn't say it's difficult. If you understand the pieces, I really don't think you should find it difficult. It's just long. But there's hundreds of functions out there above this math course that this is just the way that you represent these things. A lot of times it has to do with physics, but not always. Okay, so we have 2 more pages left. They won't take that long. And then we'll be done. And we can all take a well-deserved break. Hopefully you don't have classes after this. If you do, I'm really sorry. Determine the derivative of each function. I'll do the first one. You can try the second one. Done for the day. Okay, great. Derivative of each function. Can you just throw me the word that I'm going to write down here? What's the big keyword here? Implicit. It's implicit, exactly. The reason it's implicit, same thing I always say. There's a y mixed in with the x's. There's a y in the middle. It's not solved for y. That's a problem. And when I look at this question, I see this is okay, this is okay. This is going to be a product rule because there's an x and a y multiplied together. Oh no, you have class 3:30. I'm sorry, man. Sorry to see that. Let's do this. So let's start our derivatives. Negative 24 x to the power 5 plus 15 y to the power 4. And if you get the derivative of a y, it's the exact same as the derivative of an x, but you do the chain rule on it, which means it spits out a y prime. The derivative of the inside here is y prime. Then the product rule, which is going to be 4x cubed times y plus x power 4 times y prime. Derivative of negative 3 is 0, derivative of 0 is 0. So take a note of that, Mohammed, be careful. Could I do the one on the assignment? I think you got it wrong. Yeah, as soon as I finish this one, I'll do the one on the assignment and you can compare it to yours, okay? So what I'm going to do next is factor out the y prime. If I factor out the y prime, it will leave this and this. And I'm going to bring these over to the other side, all right? I'm going to bring the constants, or sorry, bring anything that doesn't have a y prime to the other side. So I'll do that first. That would be 24x to the power 5. When it goes across the equal sign, it changes sign. And then the other one was 4x cubed y. On the left side, I have y prime factored outside of 15y power 4 plus x power 4. And I'm going to just clean this up a little bit, but that's the big idea. Notice that I factored it out. I factor y prime out, which is why it left those terms. All that's left to do is divide by that thing in brackets. So divide both sides by this, and you'll end up getting your final answer. You can show more steps, but I've done that enough times now. I just wanted to show the basics. I'll bring up the assignment now in a second. But do you see how this is done? The broad strokes, the main ideas. Of course, you'll always need practice in order to get it yourself. Again, I'm doing this. I've got lots of experience. I've probably done hundreds of these. In fact, I know I have. I've done 6 of them just today. So don't look at me. look into yourself. Why? I'm proud of you. Yeah, thank you. Why do you have 4x cubed and x to the power 4 and 2 y's? Let me see. Okay. So I got the derivative of this, which is the product rule. So I do the derivative of the first one times the second one plus the first one times the derivative of the second one, which is really, that's what I wrote, 4x cubed times y plus x to the power 4 times y prime, product rule. Okay, so let me show you your assignment. I'll post all this online, you'll see it yourself. So, wow, didn't expect that. I don't think I wrote it like that. Anyway, that didn't help. This is the assignment question. I did the exact same products, exact same steps. You notice there is a product rule in the center. This is product rule, which means that comes out of it. Oops, not that. This comes out, that's product rule. And then the rest is exactly the same that I just did. Is that okay, Ali? Yeah, what's your question? Oh, you mean you'll be given one question about the implicit? Yeah, a multiple choice. I won't give one that's this long. I would give you something more straightforward, like, I don't know, not this, but that gives the same idea, but much shorter, okay? So you still need to figure out, you still need to know what y prime is when it's in the middle, things like that, but more reasonable. Okay, so maybe I'll just, in the interest of time, do you want to do this one as more practice, or shall we move on? I'll post the solution if I don't do it, but we've got 15 minutes left. Okay, I'll do it. So let's just do it. So the derivatives, the first one is a product rule. What I'm going to say is consider this as the first, and this is the second, and the rest follows. So the derivative of the first one is yx squared. Keep the second the same, plus the first one times the derivative of the second, y prime. That's our product rule. 3x power 5, that's 15x to the power 4 is the derivative, that's the power rule. Minus 28 y to the power of 3. X and 0 are both constants, they go to 0. What I'm going to do is bring this term and this term to the right, because they do not have y prime. In fact, I even made a little mistake here. Forgot my y prime. What happens when you do things too fast. So anytime you do the derivative of a y, it pops out a y prime. The rest follows. So I'm going to factor out my y prime. That leaves this and this. 3x cubed minus 28y cubed. That all equals, this and this are on the other side now. They're both negative. And then I just divide the entire right side by my brackets. That cancels it on the left side and brings it to the left side. Right side. Questions on that now that I've done it? Just got it. So you mean it just clicked? Yeah. And Ali, now I guess it it clicked for you too. So you had the aha moment. Yeah. It's difficult until it makes sense, in which case it's like, why don't I get 100% on these questions? So you can imagine me teaching this. It's all clicked for me, and then I need to try and figure out ways to make it click for you. And everyone has the click moment at different times. So teaching is an interesting profession, to say the least. Let's keep going. I don't want to go overtime here. We're almost done. We're almost at the finish line. We only have a couple questions left. Don't feel stupid. No need to feel stupid. You're learning. If you knew all this already, you wouldn't be in these courses. The reason is to learn. You go from not knowing it to knowing it. That's what matters. You're at the end now. You've got the idea. You can use it later. Evaluate the second derivative. What should I do when I see this question? It says evaluate, which means substitute x into it, the second derivative. You can't evaluate something you don't have, so we need to get the second derivative and put x into it. What's the very first thing I should do? Derivative, then substitute. I don't want to do the derivative of that, because if I need, can you imagine if you do two derivatives of that fraction? You'd have a massive quotient rule. It would get super complicated. So Ali got it. I did one like this on page 45, by the way. I think it's 45. I'm going to rewrite first. And if I rewrite this, which means bring the denominator up, it's not a quotient rule anymore. It's not even a product rule, to be honest. It's chain rule, which is what Ali said. So now that I've got my chain rule, I can do my two steps, derivative and then substitution. Y prime is negative 256, negative 2. And then many students forget this next step, times negative 1, because the derivative of negative x is negative 1. Many students forget that. I'll go one step further and just simplify it, because I know I need to get a second derivative, and the easier I can make it on myself, the better. All right? I just saw a negative here and a negative here, so I multiplied them together. It gave me positive 256. Now that I have my first derivative, I need my second derivative. Remember, that's the point of the question. Second derivative, bring the 2 down, multiply, negative 512. Keep the inside the same. Reduce the power by 1 again, which is negative 3. And get the inside derivative of the inside again, which is negative 1. I'm going to simplify that, and then I'll evaluate. So let's get it in a better form. Negative 512 times negative 1. 512. 512 minus x. It's the same as that cubed. Now I just need to put in x equals 8. How do I know x equals 8? Because in the beginning of the question it said for x equals 8. So I'm evaluating. Negative 8. Sorry, I just noticed it's negative 8. Y double prime is 512 minus negative 8 cubed equals, well, this is a weird answer, 1 over 274,625. $274,625, or in other words, 3.64 millionths or something. Yeah. So you got it, Mohammed. No problem about the typo. Just for learning. Okay? That would not be a multiple choice, of course. That would be a long answer. And if you know how to rewrite it, you'll make your life much easier. Okay? We've got a couple more questions left to do, so let me speed up here. I'm just going to assume you're doing okay back there. Given the function, calculate the slope of the tangent line at the point given and determine the normal line. Let's rush through this, shall we? First step, always the same as what it's been in the past. Get the derivative. Second step, substitute in your given x value. The derivative is negative 6x plus 2. The substitution for y double prime when x is, well, what is my x? My x in this case is 2. So 6 times 2 plus 2, that gives me negative 10. Why did I get that? That is the slope. The derivative is the slope function. It's the tangent line, the slope of the tangent line. So this is my slope of my tangent. It's negative 10. That's all that question wants. Don't do any more than it asks for. It wants the slope. You gave it the slope. Now in the third step, or the next step, determine the normal line. Remember, we need, in order to get the slope of the normal line, it's the negative reciprocal. I forgot to write the negative in front of the 6. Yes, I did. Thank you. This is what happens when I speed up. So I'm glad that you're still paying attention. You need to get the negative reciprocal. So change the sign and flip it upside down. 1 over 10. It's negative reciprocal. Make it negative, turn it upside down. Now, we need to continue. Our last step is our y equals mx plus b step. Our y is negative 8. Our m is 1 over 10. Our x is 2. Our b is unknown. Our b, if we solve for this, or I'll write it out, negative 8 minus 1 over 5 is what this is actually. We bring this over there. Or in other words, b is negative 41 over 5. You can check all this work after. I'm doing it quickly. Yeah, Mohammed, you got it. So our two important numbers are b and m. In this case, 1 over 10 x minus 41 over 5. M and b. So a little hint, this would be a long answer question where I asked you the normal line. But I'm also planning on asking a slope of the tangent question. That would make a really good multiple choice. So this question is actually 2 questions in 1. The full thing is a long answer question. If you just take the beginning, it's a short answer question or a multiple choice. All right, let's finish this off. We're almost done. We got very little left to do. The position of an object is given by this function. What's the velocity of the object after 2 seconds? Well, very simply put, the velocity is the first derivative of the position. This is the velocity. If you know the velocity function, all you need to do is substitute the time. We know that time is 2 seconds here. So what's the velocity when time is 2? You just need to put this in. If you work this out on your calculator, it's 52. I like to write in that it's meters per second because it is, but you don't need the meters per second. And as a side note here, velocity is the first derivative. Acceleration is our next question. At what time does the acceleration of the object reach 80 meters per second? So we have 2 things. We need to find the time when a is 80. Or in other words, we need to find a of t equals 80. But we don't need to worry about that too much. Let's just go through the motions. The acceleration is the derivative of the velocity. So look at this, derivative of that one. 30t plus 2. what do we know? That we want to know the time when acceleration is 80. So 80 is 30t plus 2. If we solve that for time, 79 over 30, which is also 2.63 seconds. I'm writing it as a decimal because it's time. And of course, time, so for A, it's 58. Sorry, I'm looking at 58, 58. Sorry, which 58 are we looking at? Velocity. 15, 2 squared plus 2 minus 6. 50. See, I'm getting 56. Oh, I see what I did wrong. Yeah, I see what I did wrong. Minus 6. 58. 58, that means that we have, I guess it doesn't change anything, does it? How are you getting 78 here? Oh, yeah, of course. Once again, as soon as you start making mistakes, bad things happen. Or in other words, as soon as you start going quickly, bad things happen. Which is probably why some people found yesterday's assignment quite difficult. Because I forced you to work fast. Okay, 2.6. Yeah, I'm shutting down 2 clearly. 80 minus 2 is 78, and then divided it by this 30. All right, we're almost done. We might as well finish it. This one's a even much faster one. What's the velocity of the object after 3 seconds? The velocity is the derivative of the position. (18 minus 5), 13. The acceleration, what's the acceleration of the object after 5 seconds? Well, the acceleration is the derivative of the velocity, or the second derivative of the position. So 6. And what you'll notice here is that if it's 6, it's a constant. You can put in any time. It doesn't change the fact that the acceleration is 6. Or in other words, if it comes out to a constant, it's always that number. So for any time t, I could give you a million different t values, it would be exactly the same. Okay, we finally made it to the end with 1 minute to spare. So I'm going to stop the recording here, and if you have any other questions, you let me know. Thanks, everybody.